Well, my name is Victor Pablo Rivera, and today I will talk to you about the applications and selection of torque converters. But before we begin on that, we will talk about what exactly is a torque converter for so many people that don't know what it is and how does it work. Well, a torque converter is a type of fluid coupling that transfers rotating power from a prime mover, like an internal combustion engine, to a rotating drum load. In a vehicle with an automatic transmission, the torque converter connects the power source to the load. It is usually located between the engine's flex plate and the transmission. The equivalent location in a manual transmission will be the mechanical clutch. How does a torque converter work? Well, in manual transmissions, they use a clutch to connect and disconnect the engine power to the transmission. But in an automatic transmission, it's the job of the torque converter to transmit and multiply the engine power to the ground. If we were to dissect a converter, inside it contains three main components: the impeller, the stator, and the turbine. First of all, the impeller or the impeller pump is located on the transmission side and rotates at an engine speed. As revolutions per minute increases, fluid flow increases inside the converter. That power is transferred using vanes and fins that direct the flow towards the turbine, which is, how do you say, bottled to the flex plate. And in between the impeller and the turbine is the stator. It functions as a sort of one-way clutch that redirects the fluid and multiplies the torque output. And when the fluid flow is powerful enough, it begins to spin the turbine, which is also spun onto the input shaft of the transmission. The characteristics of each converter are controlled by the diameter, the number and shape of fins, and starter design. And here we have an image of a clear example of how a torque converter is. In the other presentation, there was a similar image, but looking in the inside of the torque converter, how it is on the inside. Well, there are many applications, but the main ones are on automatic transmissions on automobiles such as cars, buses, and an on-off highway trucks. The second most important are forwarders and other heavy-duty vehicles. The second is the marine propulsion systems, and mostly are used on the industrial power transmissions such as conveyor drives, almost on all modern forklifts, winches, drilling rigs, construction equipment, and railway locomotives. So how do you select a torque converter? Selecting the correct converter and stall speed for your particular vehicle is critical not only on the street but also on the racetrack. The right choice can make the difference between winning and losing, between a car that performs to its potential or fails flat on performance. Choosing the best torque converter for your application can be tricky, but there are some basic guidelines you can follow to help out on the process. So, your power curve and torque output are two of the main things to consider. If we look at all stall speed are rated at 2,200 to 207,000 revolutions per minute. The range is meant to cover a variety of engine characteristics with different power curves. Ideally, you want the stall to produce more. Low and torque will increase the stall speed. Uh, and the same converter will stall at a lower revolutions per minute behind a less torquey with a higher revolutions per minute engine. You need to also consider the resistance that you will have against the engine. A heavy car with large diameter tires will create more to fight against. Generally speaking, the more resistance you have, well, the higher the stall revolutions per minute. The same principles apply to gear radios. A heavy car with taller gears, this means a low numerical value, will have a higher stall revolutions per minute compared to a light car with shorter gears and smaller tires. And finally, the most important thing is that the details will make all the difference. So to wrap up, the specifics you want to consider are, first of all, your vehicle weight, the engine displacement, the compression ratio, the cam profile, the rear end gear radio, the tire diameter, sorry, the type of fuel system, and the transmission model, and finally the year. And that is all that we should know about the applications and selection of the torque converters. Thank you.